Hi everybody and welcome to Magoosh SQL Bootcamp. Today's lesson number 2 is about the SQL language constructs. Now, SQL language commands fall into one of the three categories you see in front of you. The data definition language, which we use to create and modify the objects that will help us manage our data. For example, the tables that will hold it. The DCL, or the data control language, is a set of commands that is used to provide access control or security about which users are allowed to see or manipulate which data. And lastly, and this is the category which we're going to be dealing with the most throughout this course, is the data manipulation language, in which we actually insert, update, retrieve, and delete data from the objects that we created using the data definition language and set permissions using the data control language. So without further ado, let's jump right into our development environment. Now, as you can see, I'm using SQL Server Management Studio. I highly recommend that at least for this course you do the same. Be aware that if you're using a different environment or a different IDE, some of the things might not be the same. For example, things like the Go keyword that you see here, which is not really part of SQL, but actually a keyword that tells the editor that I want all the commands prior to it being sent as a single batch. And in this case, create object, we typically have to separate them with some sort of batch separator. Okay, but let's go ahead and start with creating our objects. Our first object we're going to create is an object called a schema. A schema, you can think about it as a namespace or as a container for other objects, which helps us manage both security and maintenance for the objects contained within it. So let me go ahead and create our Magoosh demo schema. And within that schema, I'm going to create our first table, which is going to hold our users. Now, I've chosen three properties for our users: an email, a username, and the date the user joined our system or was first inserted. And for each one of these properties or columns, as they are now part of the table, there are a few basic things that we must always tell the engine. The first thing is, what is the data type of this column? In this case, I've used varchar, which is SQL Server implementation of a variable length string, and the number in the parentheses tells SQL what's the largest number of characters that I allow for an email or for a username. So you can see we're already starting to constrain the data by setting maximum limits, but that's just the beginning. The joined on has a special date type. This is a date time, and guess what? It contains date and time. That's, again, we're enforcing some sort of consistency. It has to be a valid date. The last thing is the null or not null constraints for each column. Now, I mentioned null briefly when we discussed whether SQL was really relational or not. Now, null value is a placeholder or a value that represents an unknown value. Effectively, by stating that all these columns are not null, meaning they don't allow null values, I'm saying that they're all mandatory. As we'll see in a minute, I have the option to say whether a column, instead of not null, I can say that I want this column to allow nulls. And now the table will be able to hold rows where there is no real value for username. Therefore, it will be considered unknown. Let's create another table, our orders table. Here, I'm going to choose a different type of key because an order doesn't really exist until I generate or until I insert the row into the orders table. I'm going to use a surrogate key or an enumerator, order ID, which is an integer, which is going to be probably auto-incrementing. I'm going to start at some number and increment by 1. I also want to know which user did the order, and I want to know the order date. Again, you can see different data types, but here too I chose to make all columns mandatory. In general, you want to avoid having many null columns. That's typically an indicator that something's wrong with your design. But let's not get ahead of ourselves right now. In terms of primary key, similar to the previous table, I already said, in this case, the order ID is going to be the primary key. And I want to introduce a new kind of constraint, the foreign key constraint. Now, the foreign key constraint is a referential constraint, meaning that I want to limit the values that I allow in this column, in the user column of the orders table, only to the values that appear in the users table in the email column, which means they are valid users of my system. So now you can see we're starting to enforce data not only within a table, but also across tables. Changing a table is very easy. If I forgot to add a column, or if a requirement got added that I need to add state, all I do is alter table users, add state code. In this case, I chose char2, fixed length string with a length of 2. And because I'm adding it to an existing table, I must allow null values, because the minute I add the column, it's not going to have any value for any of the rows. After I populate that, I can change that again if I want to. I can add check constraints for email validation. I can add so many other things. I highly recommend you check the documentation and see, usually in SQL Server, there is a whole section of examples for create table and alter table, which will give you a much better idea of the options that you have here. Drop table, again, pretty straightforward. I can either drop a single table or I can drop multiple tables in a single go. I'm not going to spend any time on the DCL, on the data control language. It's most likely that in your environment you have administrative permission, so you can do pretty much everything that you want. Just to give you a sense of how it looks, it's basic English. Grant select on users to AMI means I want AMI to be able to read the data from the users table. Revoke select, take that permission away. Some engines like SQL Server also implement a third option, which is called deny. Again, I'm not going to go into the intricacies of these. If it's of any interest to you, go check the documentation. But what we are interested in is getting the data in. Getting the data in is done with an insert statement. And here we're inserting 2 users into the database. Insert users, and then the list of columns that I want to populate, and then the list of values. Now here I need a set. I can use the values clause for literal values that will be used as a set that will be inserted. And we'll see later I can also do select. I can also execute pieces of code that return set and insert them. But the most basic thing is just insert literal values like I do here. So let's go ahead and insert these. And it will help that I create the table first. Did I create the schema? Yes. So let's go ahead, create orders. And now I can insert. Okay, great. So 2 rows inserted. I'm going to jump ahead and show you the most basic form of the select statement, which is used to retrieve data. Select star means show me all columns in all rows. There's no filter, so all rows will be returned from the users table. And you can see here the 2 users that are in our system. If I need to update, I use the update command, which looks as follows. Update, table name, including schema always, set column name equals value, and here you probably want to make sure you have a filter, because if I run the update command without any filter, that means all rows are going to get updated. So in my case, I only want to update Johnny, who moved to Oregon, so I'm going to run this command and again retrieve all rows, and you can see that now Johnny lives in Oregon. Lastly, if I want to select a specific user, I can use the same filter on the select like I did before. And if I want to delete, again, you want to make sure that you have a filter. Otherwise, you're going to delete all the data from your table. So let's delete Johnny and go back, and we should be left with user Ami only, which is what we have. So let's take a quick look at what we had so far. DDL we use to define the data object, create, alter, and drop. DCL, set permissions, grant, revoke, and some engines deny. DML, insert, update, select, and delete. In the next lesson, we are going to go deeper into the various clauses of the select list in preparation for what's going to come following later, which is going to be the query logical processing, which is going to put everything in the right place. So until the next time, thank you for being here with me with lesson number 2, and hope to see you soon in lesson number 3. Have a wonderful day.